So on worksheet, is it 8? Am I on the right worksheet? Yeah. Okay. On worksheet 8, we left off at number 5. We have an object being dropped from a height of 96 feet. And it gave you the function. Now notice, that was the same function we were working with yesterday, but because the object's being dropped and not thrown or kicked or launched, there's no middle term with the velocity, because when you drop something, it has 0 initial velocity. But it does say plus 96 at the end. So what that tells me is it starts at a height of 96, which we already knew that. And then remember the negative 16 component is the acceleration due to gravity measured in feet per second squared. So you're always going to see that when measured in feet. So what I need you to do is get this function typed into your calculator. But of course we're going to use x instead of t because of the mode we're in. And then my calculator is probably still with the same window. Oh, no, it's not. My window went back to the default standard window from my previous work. I don't know what your window is right now, but I do know that t represents time. So it doesn't really make sense for me to go negative 10 seconds in the past. So let's just start time at 0. I don't really know. 10 seconds is probably far enough for the object to hit the ground, so I'm going to leave it as 10 for a maximum of my time. However, the y's, I don't mind leaving y minimum at negative 10 because if I ever have to find out when it hits the ground, I like to have a little window bottom. But I already knew the object started 96 feet in the air. So I need to be able to see that part of the quadratic. So I'm going to go up to 100. So adjust your window accordingly. Let's hit graph. Let's see what's going on. Beautiful. So objects dropping, 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 and then right here is when it hits the ground. And they want us to find out what? When does it hit the ground? So what is this called in your graph? It is a 0 or an x-intercept or a solution. So on our calculator, which is the calc menu, we're finding a 0. So number 2. And this is where you have to do a little bit of scrolling, or I'm going to do jumping because my scroll is too slow. So a time that's before it hits the ground is 2 seconds. I'm going to go with 2 for left bound. And then a time after it hits the ground would be 3 seconds. It's somewhere between 2 and 3 seconds. So when I hit enter that last time, does it say where to round? Let's just go tenths place. 2.4 seconds. Give yourself a little sketch in that box off to the side. And then also write down the window we used. So what did we go 0 to 10 for time? And then negative 10 to 100 for height. And it did something like this. Yep. All right. So, graphing calculator work, it's a good time. On the back. This is a very famous math problem, I swear. And it must be a real life problem somewhere out there, but you know, how do they make boxes? How do they... It's a more complicated question than you think. So this particular type of box has a square base, no top, and they're just going to make it no overlapping parts. They're just going to cut corners out of it and then fold up all the sides. So what they're going to ask you to do is figure out how big of a piece of cardboard we need in order to make a particular size box. So this particular question isn't super real world because, I don't know about you, I've never really seen a box where the edges just magically meet up. Usually they have an overlap. That's a more complicated question that we're going to talk about. But talk to me about this gigantic piece of cardboard. Yes, totally that. It's supposed to be a square. That didn't work out, did it? Anywho, we are going to be cutting corners out of this. And they're going to have to be the same size, right? Oh my gosh. It's like getting worse. So in order for our box to be not lopsided, everything is the same on all the sides, and then they're going to fold them up, right? Let's talk about the clues. They're going to cut 6-inch squares out of each corner. So each one of these little pieces is 6 inches. And then the last clue they tell me is that the box needs to hold 1,000 cubic inches. So this clue right here is volume. And that's kind of the heart of our math problem, is how do you find volume of a box? So for a box, the volume is length times width times height. Okay. Well, good news, guys. You know volume. It's 1,000. But let's talk about this piece right here. Do we know how long this is? Because this is going to be the length of the box. We don't know it. So in math, what do we call things that we don't know? X, yeah. And they did say somewhere, even though my picture is horribly done, it did say somewhere in my problem that this was supposed to have a square base. So even though it doesn't look like it, how long is this width supposed to be? It's also supposed to be X, isn't it? So all these are X's. Gross. All right. So the length is X. The width is X. What is the height? So if you folded these corners up, how tall, how deep would this box be? 6 inches. Very good. All right, guys, can we solve that? This is x squared times 6, so it's 6x squared equals 1,000. Go ahead and give me, I think this comes out to a decimal, and that's all right. I'm going to need you to square root whatever that number is as well. Is it 12.9 approximately? Okay. So this is where we have to be smart mathematicians and realize that we haven't actually answered the question yet. Because the question was, how big is the cardboard? So X is just from the box edge to the box edge. The actual piece of cardboard has these little corners that we cut out. So originally the cardboard had 12 additional inches on each side. So if you add those 12 inches from the cutoffs, do you guys see where I'm getting 12 from? This 6 and this 6? That means your cardboard is 24.9? Okay, by 24.9 inches. Okay, there you go. So I didn't use a graphing calculator for that question. I could have, but it wasn't worth our time because that was a simple square rooting question. So Algebra won in that little battle of what was the best method for solving. We're going to do 4,000 box problems by the end of this class. That's an exaggeration. Not that many. We're going to do a lot of box problems because they're a very famous problem in calculus, so we have to really get used to the idea of cutting corners out and making boxes. Okay, the farmer. Here we go. The farmer wishes to enclose 3 pens with fencing as shown. The farmer has 700 feet of fencing to work with. What are the dimensions that will maximize the area that's enclosed? All right. So here's our problem, guys. We really don't know anything other than the amount of fencing we have. So if you're going around an object, like technically that's a perimeter measurement, right? The problem is here it's not just a single perimeter. We've got these inner fences as well. And I don't know anything about them. So what would you like to call this depth of this part of the fence? I don't know it, so X sounds good to me. All right, so if that's an X, that means this is also an X, that's also an X, and that's also an X. Let's talk about this entire length here. Clearly it's not going to be the same, well, I don't know, maybe the picture's not to scale, but I don't think it's the same measurement as X, so you need to give me a different variable here. Y? I know, who would have thought, right? Okay. I know 2 things. I know that I kind of sort of have a perimeter measurement, kind of, and I need to figure out area at some point. Let's start with what we know. All of the fence pieces added together is 700 feet. So can we agree that if this measurement here is Y, that this measurement is also Y? So that would be 2 Ys plus, how many of those blue X's are there? 4 of them, so plus 4 X's. And adding up all those pieces, I only have 700 feet of fence. We're about to set up another equation. But that equation has to do with the area. How do you find area of, this is called a rectangle, right? So how do you find area of that particular rectangle? What would you do? Length times width. So what would that be called for us? X times y. So here's what we have, guys. You have two equations, but you have two unknown things. So you need to use an Algebra 1 technique called substitution. You need to solve for one of the variables and plug it into the other formula, and then we're going to be able to solve for the whole shebang. However, you have to solve for a variable in this equation, because this is the one we're going to need to maximize in a minute, so leave that equation alone. It's your choice, guys. What variable would you like to solve for, x or y? It does not matter. X, okay. So if you solved for x, you would subtract the 2y over, and then divide by 4. Oops, hello. So your formula for x, and don't even bother simplifying, it's 700 minus 2y over 4. Now, I kind of regret letting you have free reign on this. I almost wish you would have solved for the other variable, but that's okay. We can work with it. I need you guys to remember what we're solving for when we get to the calculator, okay? So x equals this. You can plug that in right there. So the area formula is 700 minus 2y over 4 times y. All right, here's where I got a bit of bad news. We got to graph this, because I don't know about you guys, but that looks disgusting, and I don't want to graph it I don't want to solve it by hand. I don't want to use any of my methods for quadratics. No, thank you. So this is where it gets kind of confusing, because on our calculator we're restricted by the mode of function mode, and it's only going to let us use x's. So on your calculator you're going to have to type the x. So everywhere you see a y here, you're going to pretend it's an x on your calculator, but in your brain you got to remember we're actually solving for y. So on your calculator, get this typed in exactly as you see in y1, with the exception of replacing y's with x's. Was it minus 2x over 4? Make sure you close that numerator. And then you can just say multiply by x at the end. Before you hit the graphing key, we should talk about our window. X is going to measure that one piece of the fence, like how wide the fence is. So 0 seems like an appropriate starting spot. We would not want to go negative. I don't really know a lot about this fence to know how big it could get, so let's just, for the sake of our time, go a little bigger than 10. We go to like 50 and just be okay with that. And then for y's, remember that's the length of the fence. Again, I don't really know, but I'm going to go with 0 for a starting point. I'm going to leave it at 100 and see what the damage is. Go ahead and hit graph. Okay. Did you guys get that picture too? So it turns out our window, no bueno, not good. So let's go bigger. What do you want to go? I'll try 500. Oh, a little better. Okay, this is where I just go big or go home. I'm going 5,000. Surely we'll see the maximum by then. I feel like I have something typed wrong. I don't know. You guys seeing anything weird? No? I don't know. Why didn't I? Remember those times y for area? Yeah. Oh my gosh, I just looked at the answer key. Guys, we gotta go to like 20,000. Whoa, Bruzo. Way off. Did you try Zoom Fit? Did anyone try Zoom Fit? Did it work? Sometimes this is where I give up on life and try Zoom Fit. But since I have the answer key in front of me. Go big, guys. 20,000. Oh my gosh, you know what the problem is now? I didn't go far enough in the x direction. I give up. Go big. Go 100. It's not that big. Oh my gosh. Still no? 1,000? Does that work?
500. I can see the whole thing. 500.
You can see the whole thing finally? This has been a fun experience in window fitting. 500 works great? All right, I'll go with that. My goodness. Thank you. Okay, so just in conclusion, we went 0 to 500 for the X. Wow. And then we went up to 20,000 for the Y. That was fun. Great. I still feel like we did something really silly and weird. Are we all... Did anyone catch anything weird on my problem? Not yet? Okay. I'm going to have to throw this whole video away if we screwed this question up, just so you know. You guys are going to end up in my electronic garbage. No pressure. Did you catch my mistake yet? I feel like I made one. A very large mistake. Fun. A little perseverance in the window. All right, left bound. I don't even know where my window is anymore. I'm pretty sure like 20 would be to the left of the maximum, so I'm going to go there. Oh, yeah. And then, 300? Is that definitely to the right? Yeah? Okay. Oh, I have good news. We didn't screw this question up, because that is the right answer. Now, we have to kind of filter through our answer. What did we just find? We found x equals, we're going to have to round that to about 175, right? So let's jot that down. But that's from our calculator's x, because remember I was silly and I let you guys do whatever you wanted to on the previous step. So when you solved on your calculator and got the ordered pair 175, comma, what is it, 15,300 and something? 12.5. Do you remember which one was this y that we were even solving for? This is so confusing because the x is actually the y, isn't it? So this number is actually this number, 175. So on my little pen here, I know that this dimension is 175, what is it, feet, meters? Feet. Okay, that's great. But what else do we have to figure out now? The x. I have good news for you guys though. You have a formula for x and it's right here. So if you know 175 is the y, go ahead and plug that into that formula. So 700 minus 2 times 175, and then either hit enter or use parentheses before you divide by 4. Is it 87.5-ish? Or is my key wrong? Yeah? Okay. So this farmer's pen is 87.5 feet and 175 by 175 feet. You didn't know farming was so complicated, did you? Probably isn't that complicated to make a fence, but whatever. They did want to maximize their area. And that is actually a real-life application of these. And people don't realize this, but when they do designing of not just like landscaping, in this case a farm, but like making a product on an assembly line, they want to maximize a certain component of it, and that's actually a very complicated math question. It's not nearly as easy as just trying it out. They don't want to waste $10,000 on a fence that's not going to work for them, right? All right. Oh boy, here we go. A salesperson finds that her sales average 40 cases per store when she visits 20 stores per week. And then she visits an additional store per week. Her average decreases by 1 case. So, how many stores per week should she visit to maximize her revenue? So we've created this kind of chart for you, and I'd like you to get used to using this chart because it'll help you sift through all your information. So I really like to highlight my math story problems in some way, whether it's with pen or highlighter or whatever. But the first clue says 40 cases per store is the average if she visits 20 stores per week. So first example, if she visits 20 stores, sold per store is 40 cases. So think about that as a math problem, guys. 20 stores, this would be times 40 cases. How many cases did she sell in that particular week? those. 800 total cases. And then it says, if she visits an additional store per week. So if she visits one more store, we're at 21. But what happens to her average cases per store? It says it's going to decrease by 1 case. So that would be 39. So how many cases total did she sell that mystery week? Is that 8, 19? Okay. And we could continue on doing this pattern. You know, she went to 22 stores. She'd be selling an average of 38 cases per store. So if we multiply that together, we'd get 836. Right? Are you checking my math? Because this gets really scary if you're checking my math. Or not checking my math. Alright, so here's the problem, guys. I need to set this up with algebra. So let's call this something algebraic, and then we're going to call this something algebraic, and then we're going to be able to come up with something there. Alright, here we go. How are we coming up with this green and blue number? We started with 20 cases. And then didn't you just keep adding how many extra stores you're visiting? So like this was 1 extra store, this was 2 extra stores. So can we just call that plus x? So using the same idea, how did you come up with these blue and green numbers? You started with 40. But then you were subtracting whatever the x was. We're about to reach for our graphing calculator, and your graphing calculator does not care what version of quadratic you enter into it. So we are in factored form right now, kind of, sort of. This is technically what this is, huh? Let's go ahead and type this into y1. Because look what we want to do, guys. We want to maximize our revenue. So we're going to get a nice upside down parabola, and we can find the maximum of it. Oh man, it was 20, not 40. Hey, Mrs. Offhauer. You can tell your kids in the near future I'm going to record some of that review and post it. Thanks. Alright. Now, guys, there's always... It's possible that whatever our current window is works for our problem. So before I really mess around with the window, I go ahead and hit graph. I really doubt that our last window is going to work for us, but you never know. Hit graph. That's not good. However, I can see the top of the parabola. So if I can just pull the x and y maxes way back, we'll have all we need to find is the maximum. So I'm going to go to window. I'm going to pull the x max way back. Let's go like 100. And clearly 20,000 is too big. So, I don't know. What do you want to try? Like 2,000? And again, I just need to be able to see the max. First shot of Bruzo, good job. Alright. So we need to figure out when our profit is maximized. Can you guys go find that maximum value? And then we'll kind of filter through our information to see what our true answer is. Alright, oh boy. I don't really remember what my axes were at, so I'm pretty... Okay, good. That was... So there's a pixelation issue where it's doing calculus on a bad picture, so most of you probably got 10,900. Some of you got like 9.99999. I'm getting 10.00002. Let's just agree that that's really a 10 for the x. So what we just found for our ordered pair was 10,900. So we got to think about what that ordered pair means. This is our x value and this is our y value. Yeah, but he's over there now, but I'll take it. Oh, you're okay. So the question itself says, how many stores per week should she visit to maximize her revenue? So number of stores per week, that's this column here. And we're supposed to find that by 20 plus x. So if x is 10, she should visit 30 stores. What's this 900 number? Anyone figure that out? That is the actual maximum revenue she's going to earn when she goes and visits 10 additional stores. So what happens on this question on the exam is kids get all the way set up, they find their maximum, they find their ordered pair, and then they write down x equals 10, and then they say 10 stores. But is that answering the question? No, it was 10 additional stores to the original 20. So those can get kind of complicated, but the good news is those charts really help, and they're always kind of set up the same way, where like you start putting some examples down and then you jump towards an algebra technique. All right, so let's try another one. This potter can sell 120 bowls per week at $4 per bowl, and then for every 50-cent decrease in price, 20 more bowls are sold. So this is something that companies actually have to think about. You know, if you increase or decrease your price, you do change your profit and revenue margin, but you also will change the amount of product you're going to sell. So, for instance, the first set here, 120 bowls, sells for $4. So the revenue would be, is that 480? Yeah. But if we have a 50-cent decrease in price, so what's the price if we decrease one time? It'd be $3.50. You're going to sell 20 additional bowls. So now you're going to sell 140 bowls. So if I multiply those together, the revenue is $4.90. But this is not an ever-increasing thing, right? It's, at some point, you're going to not make enough money off of the bowl itself. So let's talk algebra. And if you want to do another one, you can. You can say this is, 20 more. So 160 and then $3. I didn't come up with that number. Could someone multiply that real quick for me? 160 times 3. 480, thank you. Wait, 480? Oh. All right, so interesting. Look what happened to your revenue there. Okay, let's talk algebra. I need an algebra statement that will help me calculate a generic version of number of bowls that are being sold. So it starts at 120, but then every jump is how big? 20, so we'll call that 20x. And then for your money, for how much you're charging, it starts at $4, but then you're going to subtract 50 cents each time. So it's subtract 0.5x. All right, get this typed into Y1, because that is your revenue. And then again, guys, we're going to be looking for a maximum. I have a feeling our window for this problem is definitely not appropriate. Goodness. Was it 4 minus 0.5x? I hope. All right. I mean, a girl can dream. Let's hit graph. Oh, you know what? It's not terrible. It's not great, though. Pull your window way back. I'm going to go to like 30. Go back to like 200. The window, oh, that was stupid of Russo. 500. Too far back. 500. Thank you for the help. All right, find that maximum. Way far. Now you guys are probably just scrolling right and left to get that maximum, which is probably a more effective way. Like I said, mine has a really bad lag, so I just jump. So I just found the ordered pair 1, 490, and you really have to stop and think about what your answer is. So the ordered pair is 1, 490. The question is, at what price should we be charging? So remember, this is the formula for price. So apparently when they went down 50 cents, that was the maximum revenue option. So what price are we selling? Sell for $3.50. And what's the $4.90 then? That is my maximum revenue number that I'm going to get. Very good. All right, so now you guys have enough information. You can finish up worksheet 8, not 8B. What's the homework assignment? 9B. Remember, worksheet 9 was partially assigned to you yesterday. Now you can do the back of it. And that should be all of the homework you have so far. So you guys remember you have that Algebra Geo review. You have worksheet 7, which we got a good jump start on today. And then you have worksheet 9. You also have that review for your quadratic summative to look at, and I will get some sort of recording up in this next planning period I have.